Now, sometimes we want to solve for formulas, and those may contain more than one variable. To solve for a formula for one of its variables, you have to isolate that variable on one side of the equal sign, and everything else goes on the other side. So, for example, if I said, solve for A. This says H equals A plus T. Well, I'm going to do this just like I've been doing other equations, only this time we're not going to have numbers. We have variables in here. But still, I'm going to say, hey, what's happening to this A? And what's happening to this A is that a T is being added. So what is the opposite of adding a T? It is subtracting a T. So I'll subtract T from the right side, but then I have to subtract T from the left side. Now what I notice is that these are not like terms because they are not the same variable. So I can't combine them. I'm just going to leave it as H minus T. And H minus T equals A. I isolated that variable all by itself, so I am finished with that problem. So here is another example. I have H equals VT minus 16T squared, and I want to solve this for V. So if I solve this for V, that means I want to get V all by itself. So I have to say, hey, what's happening to V? Well, remember the steps that we just had. It says I'm going to do the addition and subtraction property first. So I'm going to get rid of this minus 16t squared. And to get rid of that, I'm going to have to add it to the right side, but then I also have to add it to the left side. So I am left with h plus 16t squared. Well, now on the right-hand side, I'm left with vt. Well, what's the opposite of multiplying by t? It is dividing by t. So I will divide this side by t. Then I have to divide the other side by t. Notice I divide the whole thing by t, not just the t part. When we're adding and subtracting, we combine the like terms that are like. When we're dividing, I'm going to have to divide the whole thing by the t. So I'm left with h plus 16t squared divided by t equals v. So sometimes books call this solving explicitly, or they'll say solving for one variable. It all depends which book that you have. They might call it solving for formulas. So I just want you to be aware of all the different things that you can hear it called. But really what it's just saying is get your variable that you want to find on one side and everything else on the other side. So here's a problem, and this says 4/3 p plus 10y equals 8. That's my original problem. So I'm going to say, hey, what's happening to this problem? Well, a 4/3 is being multiplied by t, and a 10y is being added. So the first thing I'm going to do is my addition property of equality, which means I'm going to get rid of that plus 10y, so I'm going to subtract the 10y from both sides. So I subtract it from here, it disappears, I need to subtract it from that side, and I'm left with 8 minus 10y. I cannot combine these because they are not like terms, so I just leave them like they are. Well, now I have 4/3 times p, and I want to get rid of this 4/3. Well, the way I get rid of this 4/3 is to multiply by the reciprocal, because 3 times 4 gives me 12 on the top, and 4 times 3 gives me 12 on the bottom, and 12 over 12 gives me 1. And by the way, that's the definition of a reciprocal. A number and its reciprocal multiplied equal 1. So if I multiply this side by the reciprocal, I'm left with just p on the left-hand side, and that was my goal. But hey, if I multiply the left-hand side by 3/4, I have to multiply the right-hand side by 3/4. So I have 3/4 times. Now I need to be careful. I'm not going to just times the 8. I need to multiply it to the whole thing. And that is where I see students make mistakes often, is they just multiply it to one part. But I need to multiply to the whole thing. So here I'm going to have to use my distributive property. So 3/4 times 8, and then 3/4 times negative 10y. Well, 3/4 times 8. 4 goes into 8 2 times, so I could cancel that with that 8 and get 2. And 3 times 2 gives me 6. And negative 3 times 10 gives me a negative 30 over the 4y. And there is my answer. 1/4.